I'm excited to introduce the Society Pregnancy, Postpartum, and Infant Neurodevelopment Study, also known as SPIN. My name is Maria Ospina, and I am the principal investigator of this fascinating study that seeks to understand if gut microbiota is a biological middle step linking social conditions with mental health in pregnant people and with brain development in their children. In this presentation, I would like to discuss how this is possible, how social factors can get under the skin to produce changes in our health. One of the unique aspects of SPIN is our focus on the gut microbiota. We are investigating the role of the microbiota in the gut as a potential mediator in the relationship between social factors, maternal mental health, and child neurodevelopment. Designing a study like SPIN comes with several challenges. I will discuss the challenges of recruiting and analyzing data from a socially diverse population and propose a few strategies for recruitment, data collection, and knowledge translation. But why SPIN? Mental health disorders during the perinatal period affect 10 to 25% of perinatal individuals. Up to 1 in 5 mothers experience postpartum depression with high rates of anxiety symptoms. These conditions present a major global public health challenge with significant consequences for mothers, children, and families. Worldwide, over 200 million children under the age of 5 are at risk of developmental delays every year, with neurodevelopmental disorders affecting between 7 to 14% of children in industrialized countries. These disorders vary from mild to severe, impacting personal, social, and academic functioning across the lifespan. In Canada, when untreated, perinatal mental illness costs about $7 billion every year, and about 70% of these costs are attributed to adverse effects on children, including poor cognitive functioning. Improving maternal mental health and child neurodevelopment are global health priorities, especially among historically and socially disadvantaged groups. If we want to design effective early interventions, it's crucial that we understand how social and biological mechanisms shape and sustain health in the social environment, both in early life and adulthood, is one of the strongest predictors of morbidity and mortality risk in humans. In social mammals, including humans, social conditions powerfully shape the environment that individuals experience day to day. Adverse social experiences, in particular, elicit biological responses across social species that influence health and aging across the lifespan. So it's not surprising that dimensions of the social environment in humans, particularly socioeconomic position, social integration, and early life adversity, are among the strongest and most consistent predictors of health and survival outcomes. To understand how these social influences impact the health of individuals and communities, we talk about social determinants of health and about social location. These are related concepts that help to understand how societal factors impact the health of individuals and communities, but each serves a different purpose and focuses on distinct aspects of social influence. For example, social location refers to an individual's position within society, shaped by various social identities and demographic factors. It centers on who is the individual, their identity, and how these intersecting identities shape their experiences and perspectives. Social location is a concept that helps explain why individuals might influence privilege or marginalization and shows how their identities influence their worldview, access to resources, and interactions with others. An individual's social location often shapes their access to social determinants of health. For instance, a person's social location as a low income, racialized, new immigrant individual might limit their access to quality education, safe housing, or healthcare, which in turns affect their health outcomes. This concept of social location is often used in the fields of sociology or psychology and anthropology to explore identity and power dynamics. Social determinants of health, on the other hand, is a concept used in public health and policy making to address health disparities and promote health equity. While social determinants of health are essential for understanding broad structural factors affecting health, they can sometimes oversimplify individual experiences by focusing on general categories like income or education level without capturing the intersecting identities within these categories. Social determinants often overlook the complex layers of individual identity. By focusing on population level factors, they can miss how multiple forms of disadvantage intersect to impact health outcomes on a personal level. By centering on identity and intersectionality, social location is a more powerful concept for understanding the gradients and layers of social privilege or disadvantage. This is a concept that aligns well with the goal of capturing how different identities interact to shape unique experiences of marginalization and privilege that go beyond any single factor. Social location is able to capture overlapping identities, acknowledging that disadvantage is not a binary experience, but is something that exists on a continuum. And this approach gives a more comprehensive view of social standing, recognizing that one might experience privilege in some areas and marginalization in others. But how do social factors get under the skin to influence health outcomes? Much of biomedical research has centered on immediate psychological and biological causes. However, these factors are, in fact, intermediaries on the path from social position to health or disease. In this model, the ecosocial model, a person's biological status reflects their material and social history. Essentially, their past social experiences are inscribed into the body's physiology and pathology. The concept of embodiment was coined by social epidemiologist Nancy Krieger to illustrate that the social world is literally embodied and that to fully understand our biology, we must consider the historical and the societal contexts in which we live. The biological mechanisms by which social factors impact health trajectories across the life course remain poorly understood. The concept of biological embedding, which is grounded in the developmental origins of health and disease framework, offers interesting insights into how social influences get under the skin. Biological embedding describes a process about how social environments can alter key biological processes, ultimately affecting health. In this framework, socially stratified exposures activate immunological and metabolic responses, which generate biological changes. This process is dynamic, it occurs repeatedly over time, and shows sensitivity to critical periods in which these exposures occur. Biosocial inheritance provides a framework to study the intergenerational transmission of health inequalities. It describes how social adversity in one generation is passed to the next through interconnected biological and social mechanisms, which together exacerbate health and social inequalities. This inheritance from our parents, grandparents, and the society in which we grow up is shaped by both biological and social factors that strongly influence each other. In this model of biosocial inheritance, social locations and health disparities are reinforced across generations, transmitted through biological pathways and socially driven behaviors. Understanding the biological mechanisms that mediate these effects during sensitive life periods is a major research challenge and a crucial step towards developing strategies to intervene, mitigate, or even reverse their impact. The gut microbiota has recently been identified as a possible mechanism for the biological embedding and biosocial inheritance of social factors. Emerging evidence from animal and human studies suggests that gut microorganisms communicate with the brain through the microbiota gut brain axis, influencing mental health and neurodevelopment by immune, endocrine, neural, and metabolic pathways. The microbiota can produce neuroactive substances like serotonin and dopamine, which impact mood and cognitive function. Gut microbiota imbalances have been associated with mental health issues, including depression and anxiety, and autism spectrum disorders. During pregnancy, the maternal gut microbiota adapt to support both maternal and offspring health. And similarly, gut microbiota composition in early life is essential for brain development, supporting neurogenesis, synaptic pruning, and immune maturity. These processes are essential for cognitive function and mental health resilience. Despite this evidence, there are still gaps in understanding how social factors intersect with these processes, and this knowledge gap is partly due to a lack of diverse cohort studies that address the complexity of these relationships. And that is how we propose the SPIN study as a way to examine the role of the gut microbiota as a plausible biological mechanism linking social locations, maternal mental health, and child neurodevelopment. We have three objectives. Objective number one is about examining the association between social location and changes in the diversity and composition of maternal and infant gut microbiota. The second objective evaluates the mediating role of the gut microbiota on the association between social location and maternal mental health outcomes. And finally, the third objective investigates the role of maternal and infant gut microbiota in mediating the effects of social location on child neurodevelopment. Improving maternal mental health and child neurodevelopment, especially in disadvantaged groups, is a key public health priority. So, if the gut microbiota mediates these inequalities that affect many of these populations in disadvantage, the microbiota could become a target to reduce the impact of adverse social conditions on health. In Canada's diverse population, identifying social factors that influence the gut microbiota during sensitive periods of life could lead to better strategies for reducing health disparities. And this is how we introduce the SPIN cohort in Edmonton, Alberta, in Canada. We have launched the cohort in early November. Um, and look for the recruitment of pregnant persons aged between 18 and 49 years without pre-existing chronic conditions. We have established 6 time points in the follow-up period, starting in the second trimester of pregnancy until the child turns 36 months of age. During this follow-up period, we will apply questionnaires. We will collect stool samples for analysis of the gut microbiota, and we will also conduct neuropsychological assessments in the child and evaluations of mother-child bonding. We have proposed a multimodal recruitment strategy that promotes participation and retention among equity-seeking and deserving populations, while providing sufficient variation in the socio-demographic characteristics of the cohort. There is evidence that pregnant persons with indigenous background, recent immigrants, and those from low-income settings are less likely to access timely prenatal care. And that's one of the reasons why we will complement clinical recruitment with other community-based strategies to ensure that all potential social locations are represented in the study. So we have our enrollment using social media channels like YouTube, Facebook, Instagram, X platforms, TikTok, but also we have a community engagement component, and very interestingly a neighborhood georeferencing approach to making sure that we have representation from pregnant persons from all walks of life. We have already georeferenced all city neighborhoods and classified them into deprivation quintiles based on an area level measure, the Pampalone Index, that integrates data from the 2021 Canadian Census on income, education, employment, marital status, one person's household, and single parent families by dissemination area. So this is a measure at the neighborhood level, is an aggregated level measure, not an individual based measure. So this Pampalone Index classify different areas of the city into quintiles that go from Q1, which is the least materially deprived, to Q5, which is the most deprived. In SPIN, once a pregnant person is eligible to enter the study, we collect information about their postal code of their usual place of residency, and we georeference and classify it into one of the 5 Pampalone quintiles. This slide presents the distribution of women aged between 15 to 49 years across the different material deprivation quintiles based on the 2021 census data. And we have aligned this information with the percentage of pregnant women per quintile from the Alberta Perinatal Health Program. This program records all deliveries that occur in the province of Alberta in hospitals or delivered by midwives. Using this data, we projected the sample size that we need for the study uh, in order to represent each quintile proportionally according to the observed 2021 pregnancy rates. To ensure a comprehensive representation of these different social locations, we will use georeferencing for stratification and quota sampling. We hope that this approach will allow to capture the diversity across deprivation levels, at least on an area level aggregated form, to make sure that women from all social backgrounds are included in the study. This is an example of how our maps look like in trying to track where the different postal codes from women can be mapped and georeferenced and understand how can we capture all women for the recruitment across the city. We're also using the maps for knowledge translation purposes. So we have our study website, www.spin.ca, and we are presenting information with these maps on where are we recruiting women in our study according to the different districts in the city of Edmonton. For our data collection strategy, we have combined the use of online questionnaires via RedCap. We have a collection of stool samples by women at home. We have in-person neurodevelopmental assessment of children, and we also have a evaluations of the mother-child interactions by video recording during these in-person visits when children come with their mothers for the neuropsychological assessments to our research center. So these are the different measures that we will collect starting from the second trimester until the child turns 36 months. For the measure of social location, we are collecting information about the traditional social determinants of health like gender, marital status, education, occupation, income, time to immigration, language, religion, disability, but we're also including other measures that are more multidimensional and reflective of individuals' social location in relation to experiences of discrimination, a perception of their home environments, their neighborhood environments, collective efficacy, family functioning, the perception of social support and green space exposure, experiences of food and housing insecurity, access to health care and medication, transportation, uh, adverse childhood experiences, and also their perception of subjective perception of social status. For the analysis of the microbiota, we will use taxonomic profiling in which we will identify bacterial taxa down to the genus level by sequencing the 16S rRNA gene. Since all bacteria have the 16S rRNA genes, it serves as a universal marker for bacterial identification. So with this analysis of relative abundance, we will quantify the proportion of different microbial taxa within a sample at the operational taxonomic unit level. So these OTU are used to classify groups of closely related microbes or bacteria based on the similarity of their genetic sequence. So this is how this analysis of relative abundance might look like in our study. We will have evaluations for both mothers and infants across the four different time points, and we will be able to provide a description of the proportion of different types of um, bacterial tassa at the OTU level in each time point. We have included measures of alpha diversity to measure microbial richness within individual samples at the OTU level. And common indices include the Shannon index, the Simpson index, and the Chow-1 index. In our analysis of gut microbial diversity, we will use these three indices to measure diversity within the gut microbiota community. Beta diversity measures compare microbial composition across samples or groups. And some of the measures are the Bray-Curtis dissimilarity, the Jacquard index, and the unifrac distances. This graph here illustrates a comparison of microbial composition using Jacquard distances. Shorter distances between any pair indicate greater similarity in microbial communities. In this case, the symbols represent means with bars showing 95 confidence intervals. So this is basically a forest plot that shows comparisons of gut microbiota at different sampling times, distinguishing distances between samples from the same individual at different time points, and also distances between unrelated children or unrelated mothers. This approach helps to understand how microbial communities differ within and between individuals over time. The study outcomes are maternal depression and anxiety symptoms measured with the Edinburgh Postnatal Depression Scale and the General Anxiety Disorder 7 scale. We will evaluate child neurodevelopment using the Bailey scales of infant and toddler development, the fourth edition, and reporting age adjusted standardized scores in the domains of cognitive, language, motor skills, social emotional, and adaptive behavior. We're collecting information about other variables that are important for the relationships that we want to explore. So, for example, maternal and infant diet quality and infant feeding practices, including breastfeeding, are very important variables because of their association with gut microbiota abundance and diversity. Physical activity in pregnancy and substance use during pregnancy are also important because of a potential relationship with changes in the gut microbiota, but also because of their relationship with mental health in the mother. Measures of mother-infant dyadic relationship, maternal resilience, sleep in both mother and child temperament are variables that are important for both mental health and child neurodevelopment. So we need to measure these variables in our study. We're collecting other study variables from the electronic medical record, and these measures are related with obstetric characteristics, age at delivery, priority, gravity, and potential complications such as gestational diabetes and preeclampsia. We're collecting information about perinatal factors related with the mode of delivery, potential use of antibiotics during pregnancy, labor, or immediately after birth, any history of mental health or any comorbidities, and neonatal characteristics related with child sex, gestational age at birth, and the presence of any alterations in fetal growth and duration of gestation. For the analytical framework and modeling, we're proposing Latin class and principal component analysis. Um, the Latin class approach can identify classes that represent different social locations or clusters that cannot be explained as the sum of their parts. Individual variables in these clusters are not related with, or not treated with equal weights. And this approach can provide a categorical or ordinal representation of social gradients. We will also explore the use of principal component analysis for the analytical strategy. For we are proposing longitudinal mediation analysis using structural equation modeling. The longitudinal structure of the structural equation model is a robust approach that accounts for the intra-individual correlations of multiple outcomes and covariates measured at different time points over the follow-up. What is new about SPIN is the concept of social location as a intersectional measure that reflects the diversity of identities in the study participants. Uh, the inclusion of a diverse cohort of pregnant persons with different gradients of social advantage or disadvantage, privilege, and marginalization. The use of georeferencing for stratification and quota sampling to ensure that all potential social locations are represented in the study, and also the engagement of community organizations, community champions to enhance recruitment and retention is another important aspect in the SPIN study. SPIN has some challenges. For example, the recruitment of a diverse sample is one of the first major challenges in designing this study, particularly when we want to reach diverse social populations. We have tailored our recruitment strategies, including social media, but also community based recruitment and collaboration with local organizations to reach underrepresented groups. So, partnering with community leaders help to build trust and ensure that our study population is inclusive of those that have often been left out of traditional research studies. Retention is always a challenge in longitudinal research. Our cohort spans from pregnancy to 36 months postpartum, making engagement over this extended period of time a very challenging task, and this requires several retention strategies. For instance, we plan multiple touch points and frequent follow ups to sustain participants' interest. We have also considered practical supports like flexible scheduling, helps with transportation, and financial incentives to encourage ongoing participation. Data collection has its own set of challenges, especially with the logistics of collecting stool samples from both mothers and infants at home. So ensuring the integrity of these samples is crucial. So coordination of delivery and storage of these samples has added a complexity to the study design. Social locations are multifaceted and intersect several individual factors in very complex ways. So, to capture this complexity, we propose a Latin class analysis approach, allowing to examine these intersecting social factors as a whole rather than in isolation. This analytical approach reflects the reality of participants' lives but comes with additional data processing and modeling challenges. A unique aspect of our study is the hypothesis of the gut microbiota as a mediator of the effects of social location on maternal mental health and child neurodevelopment. And testing this hypothesis requires linking biological and social data in meaningful ways. This intersection is challenging because it involves disentangling the effects of social influences from biological mechanisms. To do this, we are applying sophisticated longitudinal mediation models, which helps to analyze the role of the microbiota as a mediator while accounting for multiple factors like nutrition, diet, sleep, stress, mother child attachment styles, child temperament, medications use, among other variables. Our study includes sensitive populations who might be at a greater risk for mental health challenges and neurodevelopmental issues. This introduces ethical considerations as we need to ensure these participants feel supported and that they trust our research process. We address these by offering appropriate referrals for mental health and developmental support when needed, and by working with community organizations to ensure that we respect cultural and social sensitivities. Um, for example, We have designed our red cap questionnaires in a way that when a particular cutoff for identifying depression symptoms is identified for a particular individual in the study, that will trigger a referral for mental health and support. For neurodevelopmental assessments, we are preparing parental reports of these evaluations to be shared with the parents. Building this support structure is essential to promote both trust and participant well-being when taking part in the study. Another critical aspect of SPIN is that the research connecting social factors with microbiota is still limited, looking at social factors one by one, so we are navigating largely uncharted waters here. Our study's novelty is exciting, but also represents analytical challenges as we are essentially pioneering methods to explore these intersecting relationships and interpreting findings about such complex social and biological interactions. Sample size and attrition are critical considerations from the start. The sample size for SPIN was calculated thinking on high attrition rates, especially among disadvantaged populations, and a high attrition rate might introduce bias and impact data quality. A sample size of 420 pregnant person child diets is required to detect a Cohen's d effect size difference of at least 0.2 in the study outcomes by maternal social location groups. We have projected an attrition rate of around 30% over the course of the study, meaning that with a sample of 600 pregnant person child diets, uh, this will be sufficient to reach the effective sample size of 420 pregnant person child diets for the analysis. Our study is multidisciplinary. It involves several disciplines such as microbiology, epidemiology, mental health, and social science. Integrating these disciplines and methodologies is both a necessity and a challenge. Coordinated across these disciplines requires aligning our methods to ensure consistency and accuracy when we bridge the knowledge gaps that we aim to fill in. Social location uh, is indeed a powerful concept for understanding gradients and layers of social disadvantage. It aligns well with the goal of capturing how different identities interact to shape unique experiences of marginalization and privilege. So, for take home messages, the SPIN study aims to deepen our understanding of the gut microbiome as a biological pathway between the social world and health. And by investigating this role, we hope to inform the design of multifaceted interventions to mitigate health disparities in maternal mental health and child neurodevelopment in a targeted way. We also expect to expand the SPE population as we move forward. This is our research team with members from Queen's University, University of Alberta, University of Calgary, McMaster University, Brock University, all in Canada, and also the University College Cork in Ireland. The SPIN study is funded by the Canadian Institutes of Health Research and the Canada Research Chair Program. So we expect to share with you more updates about the SPIN study, and in the meantime, don't forget to follow us at the SPIN www.spin.ca. Thank you.